Question number 11.16. Explain how does the OH group attached to a carbon of benzene ring activate it towards electrophilic substitution. Yes, this is true that in benzene, electrophilic substitution is taking place. Now, what is electrophiles? Electrophiles are the species which is electron deficient, like chlorine plus ion or NO2 plus ion, or any species which is electron deficient is known as electrophile. And we know that in benzene, electrophilic substitution is taking place because benzene is electron rich. 6 pi electrons are present in benzene ring, and because of these electrons, 6 pi electrons, benzene is electron rich. So here attack of only electrophiles can take place, and that is why in benzene electrophilic substitution is taking place. Now what happens, how the OH group activates benzene ring, and that means it is increasing the electron density of the benzene ring by giving electron, and that is very clear when we are making the resonating structure. So in the benzene, already electrons are present. It is further activated and electron density is increasing in the benzene ring when OH group is present. So to understand this, we are making all the resonating structures of the benzene ring. First of all, this electron pair of the oxygen is making the bond between oxygen and carbon, and this bond will not be here, and it is forming the charge over here. And by this, we will have the structure, that is second structure, in which double bond is present here and oxygen is attached to hydrogen, and now this oxygen is having positive charge because it is giving the electron, and negative charge appears here. And after that, this negative charge and this bond will remain as such. It is not disturbed, and in the next structure, electron is further shifting, and this charge is forming the bond in between these two carbon atoms, and this bond will not be here, and it is making the charge over here. So you should be very clear about the movement of the electrons, and the arrow should exactly point the position. And here again, we are making the same thing. Double bond is now coming over here. This double bond is not here, and it is forming charge. This double bond is not disturbed, and this double bond is formed, and here oxygen is attached to hydrogen with the positive charge. In the next step, the electrons are shifting and forming bond here, and this bond is making the charge over here. And that is how in the next step we are getting the next structure. So double bond is now coming over here. This double bond is as such not disturbed. This charge is appearing here, and double bond with oxygen and positive charge and hydrogen will remain as such. Now in the next step, again electron is shifted from here to form the bond, and this electron pair is going back to oxygen, and we are getting the last resonating structure. Double bond here, double bond appears here. Now we are getting the double bond here also, and here single bond is left, oxygen with both the electrons but no charge. And this is the last one, and here we can see that oxygen is OH group is actually giving electrons, and by that it is increasing electron density at the benzene ring, and particularly at ortho and para position, negative charge appears. So it is increasing the electron density at ortho and para position, and by that it is activating benzene ring for electrophilic substitution. Substitution.